Now we'll work through the next 4 questions. State the possible rational roots for each equation, then factor each. All right, so when we come across a rational equation, polynomial equation, in order to find the rational roots, we use C and D. So remember C, that's the factors of the constant. So factors of 2 are plus or minus 1 and plus or minus 2. And then D, the values for D come from the factors of the leading coefficient. So plus or minus 1, plus or minus 2, and plus or minus 4. And so we want all possibilities of C over D. We have 1 over 1, which is 1. 1 over 2, plus or minus 1/2. And 1 over 4, so we have plus or minus 1/4. Now come the 2 over each of our D values. 2 over 1, which is plus or minus 2. 2 over 2 is 1. We already have it. We don't have to write it again. 2 over 4 is 1/2. We already have it. We don't have it to write it again. So there's the first part. State the possible rational roots for each equation. We did that. Then factor each. All right, well, we're going to factor each. So what we'll do is we'll take our possibilities here and start trying them in synthetic division. So let's start with positive 1. We're going to set this up for several of them as we try this. So actually we don't want this one here, we want the one down here. We're going to list the coefficients for -1, -8, and 2. We bring down the 4. 1 times 4 is 4 plus -1 is 3. 1 times 3 is 3 plus -8 is -5. And 1 times -5 is -5 plus 2, which is -3. We're looking to get a 0 here, which is our remainder column. We didn't, so let's try something different. Let's try 1. Sorry, we did that already. -1. Bring down the 4. -1 times 4 is -4. Minus 1 is -5. -1 times -5 is 5, plus -8 is -3. And -1 times -3 is +3, plus 2 is 5. Still didn't work. I'm going to go ahead and keep sticking with integers for now. So we're going to go to 2. You bring down the 4. 2 times 4 is 8, plus -1 is 7. 2 times 7 is 14, plus -8 is 6. 2 times 6 is 12, plus 2 is 14. 14. And then still didn't work, so try -2. Bring down the 4. This is -8 minus 1 is -9. -2 and -9 is +18, plus 8 is 10. -2 times 10 is -20. Minus 2 is -18. So none of the integers work, so now we're going to have to deal with fractions. So let's go to 1/2. Still works, just fractions, so bring down the 4. Half of 4 is 2, times plus -1 is 1. 1/2 times 1 is 1/2. -8 is -7.5. -7.5 is -15 halves. And then multiply that, that's -15/4. Plus 2 is not going to give us 0. Not 0. Let's try -1/2. Bring down the 4. -1/2 times 4 is 2. Is -2, and -1 is -3. This will be 3 halves. So this would be 6.5. And then half of that will give us, not give us 0. Well, we're getting our work out here. We're running out of room, so we're gonna have to rewrite this. -1, -8, and 2. Well, we only have the quarters left, so let's try 1/4. Bring down the 4. A quarter of 4 is 1. 1 plus -1 is 0. Quarter of 0 is 0, plus -8 is -8. A quarter of -8 is -2, plus 2 is 0. We found it. So we know that x minus 1/4 is a factor. Then we write this part, which is called the depressed polynomial. The original was x cubed. We divided by an x, so we're down to x squared. So this is 4x squared minus 8 equals 0. We can factor out a 4. So we have 4x minus 1/4 and x squared minus 2 equals 0. And we can stop here because this one is not factorable within like rational numbers. We could keep going if we wanted to, and we could realize that this factors to x plus root 2 times x minus root 2. However, we don't need to do that. So then factor each. So factored. I want to throw this out here. I'm going to hate that I just went through that whole thing and now I'm showing this to you, but there is a quicker way. Doesn't always work for all polynomials, not even all polynomials with degree 3, but it does, and if you recognize it, it can go much quicker. And so it's called factoring by grouping. We've seen it before, but haven't used it for a while. What you do is you, if it's a trinomial, and again, it doesn't always work, but you might recognize it because these numbers are somewhat related. What you do is, if there's a negative here for our third term, we think of plus a negative because we don't want to mess things up here, so plus a negative. If you don't do that, your grouping will end up being wrong because it will look like you're distributing a negative and you shouldn't be. So we group like that, and then we factor out what's in common in those groups. So there's an x squared in common here. What's left? Well, a 4x minus 1, because x squared times 1 gives us this x squared here. We have plus here, and I notice I have a 4 here, a positive 4, so it would be great if I could have a positive 4 here. Well, I can if I factor out a negative 2. If I factor out a negative 2, we're left with 4x minus 1. And notice we have the exact same term here and here. So what we actually do is we factor out that 4x minus 1. And what's left over after we factor that out? Well, x squared minus 2 equals 0. And you might think, hey, well, that's not the same as this up here. It is. If we distributed this 4 in here, we would get 4x minus 1. So there it is, 4x minus 1. Again, we could keep going with this, but there you have it. Next one, state if the given binomial is a factor of the given polynomial. Well, we can check by doing synthetic division. So put a -5 out here. List our coefficients. Make sure if there's a missing degree that you put a 0 in that spot. There's not here because there's an m, 1m to the 4th, 7m cubed, 20m squared, 56m, and then just a 30 as a constant. And so we can work through this with synthetic. We bring down the 1. Negative 5 times 1 is negative 5. Plus 7 is 2. This will be negative 10. And we get 10. 20 minus 10 is 10. Negative 5 times 10 is negative 50. It's looking good. We get a 6 here. Negative 5 times 6 is negative 30. And this is 0. State if the given binomial is a factor. The answer is yes. How do we know it's yes? Because we got a remainder of 0. Next couple. Describe the end behavior. End behavior of polynomials. We learned about this. We learned that sometimes the degree is, actually we usually start with even, or it's odd. And we then, so this is degree, and then the leading coefficient, we'll just abbreviate here, the leading coefficient is sometimes positive and sometimes it's negative. And what we learned here, if it's even and positive, they're both up, so we put up, up. This means the left side goes up, and this means the right side goes up. If it's even and negative, they're both down. Both tails go downward, down, down. We learned odd means opposite directions. So odd and positive, the left is down and the right is up. And odd negative is the opposite of that. The left is up and the right is down. So realize the order of writing this is important. The first one is the left side, the second one is the right side. Well, let's just now check these out. This is even degree and it's positive. So even, positive, they're both up. Another way as this is written, I think in the answer key, it would say f of x, which is the function, the y value, keeps going up, so approaches infinity as x goes up. So as x keeps getting bigger and bigger, the function approaches infinity, and it approaches infinity as x gets smaller, or x approaches negative infinity. So that's how it's written in the answer key. Over here, we just have to look at this term. It's negative and odd. Negative and odd, so this is up on the left and down on the right. So the other way to write this, we don't have to write that, just up and down, is as f of x, or x of f of x approaches negative infinity. So we actually look at this part first, the right side, as x approaches infinity. And f of x gets larger and larger. It goes up, approaches positive infinity, as x gets smaller and smaller, the left side.